Good afternoon. Thank you for joining us at Authenticate 2021. I'm Nathanael Coffing, Chief Strategy Officer of CloudIdentity, and here to talk about bringing in FIDO-based authentication combined with consent to create a zero trust landscape for your consumers. As we think about how we engage with our business partners, our customers, our employees, right, it really becomes important to think about what does friction look like and how to lower that friction at every step of the customer, employee, partner journey, and how to secure and reduce risk with that friction as well, right? And that's really where that zero trust adage comes from, like bringing this all together in a very common, cohesive, orchestrated manner to give the best possible user experience. And as we start, I'd actually like to kind of just throw a couple of definitions out there. There's going to be terms we're going to use throughout the course of this presentation, but I think it's important for us all to be on the same page to start. So first, and hopefully everybody knows this one, FIDO, right? That's the specification for authenticating users to online services, not depending on passwords, typically using web Authn, things of that nature, so I can authenticate directly to my mobile device or to a device. OAuth, it's a delegated authorization framework for RESTful APIs, although now it's also starting to be used for gRPC and GraphQL APIs that delegates authorization, right? Decoupling it from authentication, right? So it's a wholly separate spec than FIDO. OIDC, that's a very simple identity layer that sits on top of the OAuth 2 protocol, allowing clients to verify the identity of the end user. You'll hear ACR record or AMR record. That is the proof that the user authenticated strongly as they go through the course of a transaction. OPA, Open Policy Agent. This is a Cloud Native Computing Foundation project that's being widely adopted as a replacement for XACML and can work in conjunction with some of the advanced OAuth specs that are coming out, in particular, rich authorization requests, push authorization requests, and obviously with OIDC. Finally, zero trust, right? This word gets bandied, or this term gets bandied around a bunch. We want to just kind of set the record for what we consider zero trust and, well, what O'Reilly and the rest of the industry has defined it as. And that's really authenticating everything that's in a transaction. That's every identity: the identity of the user, the identity of the service they're accessing, the identity of the client on their mobile device, the identity of the backend services that the front end service might be passing to. And then zero trust authorization takes that one step further, authorizing each and every data element that gets passed from the user to the client to the service, and the service to any backend APIs. So being able to really constrain and authorize how data flows from the inception of the transaction, authenticating via my FIDO device, all the way down to the completion of the transaction, which could be multiple API calls out to different SaaS companies, out to Workday, out to Salesforce, as well as within the portal or the service that I'm talking to. And why are we talking about this, right? One of the big things is identities holding digital transformation hostage. We see this over and over again. Companies have purchased, 1 to 5 different IDPs. Some of them were built in, the early 2000s. Some of them are more modern. And depending on when they created their application, what their application infrastructure looks like, they're all using different IDPs, different privacy settings, different authenticators, from FIDO to user ID passwords. And they're not able to treat it in a common cohesive manner. They're increasing friction because they haven't normalized what authentication looks like, what OIDC or what their IDP looks like, what authorization looks like, what consent looks like, and obviously they're completely unable to build a zero trust framework for their customers based on that. So why are they being held hostage? Well, we need to actually look at the IDPs we have today. And typically, again, most organizations have 2, 3, sometimes 5 different IDPs. And they're all, well, the majority of them are monoliths. And those monoliths have combined all of the functions of IAM, authentication, authorization policy management, consent, normalization into this monolith, right? And that monolith isn't able to span multiple clouds, multiple API gateways, support distributed application infrastructure. And so to peel back that onion, we're actually going to start separating those into their own, essentially, identity microservices, an authentication microservice supporting FIDO, an IDP microservice that's bringing in the context of the user that supports OIDC, normalizing of the data, coarse and fine-grained authorization using things like OPA, and then also layering right on top, obviously, OAuth to make sure that we're following standards from service 1 to service 4. And then also we're seeing the advent of the OAuth grant spec designed to bring consent in as well. So being able to use open standards, right, to start to provide all of these discrete, distributed identity microservices out to your different applications. So your application developers can pick up the ones they need and move as quickly as possible. So when we start thinking about, okay, what does that zero trust for consumers look like? Let's start at the authentication journey, right? FIDO's been around for quite a while now, and we're really starting to see the industry push and adopt, right? So first part is how do we embrace with our heritage, right? We're not going to rip and replace and take out all of those existing IDPs today, but we need to start leveraging FIDO, right, for our standard authentication. So we build an authentication service, a FIDO-based authentication service, and then we need to use SDKs or APIs to integrate with the existing IDPs. So we're authenticating with standards. We're also bringing in the ability now for the user to start owning their own biometrics data. There's no need for that biometrics data to go across the wire with FIDO. Now it can be stored locally on their device, right? Strong authentication down to your device. And now my client needs to be strongly authenticated. The big value here, right, is we're getting low friction. We're getting passwordless, no more to remember, no more to forget. And then making sure that obviously we're building that interconnectivity layer, again, via APIs primarily, SDKs if you have to. But the key here is starting to build the bridges between these different services. So the second step is normalizing what that IDP and the data coming from them looks like. And so if we look at the IDP data, right, typically the IDP is doing user management. It's kind of the easy way to think about it. Sometimes you'll layer on top things like entitlements or a little bit of consent, depending upon how rich the IDP is. But we know we need to get data typically from multiple IDPs because we want a common user record for, again, the best possible user experience. We might actually have to go out to Active Directory, for example, to bring in security groups or roles. We also might want to go to different entitlement stores to bring in better data for how an application should look and feel, how it should interact with the user. So being able to pull together data from, NoSQL, a GraphQL, a SQL, and bring all that data, munge it, and normalize it so every application sees that data in the exact same way. There's no more responsibility for the application owners to actually go out and grab that data. Now it's going to be provided to them through that OIDC token, either as a grant, or it could actually become as an additional JOT, depending upon how you'd like to configure it. So now that we've got our user authenticated strongly to FIDO, then going over to the IDP, aggregating the data, so we know exactly what data should flow to the different services. Well, how do we build out that zero trust bridge to the clients and the backend services? This is really where OAuth comes in a very big way. So OAuth has released in the past few years additional specs around dynamic client registration. And you can continue to use things like client credential flow, but now you're actually automating it. In addition, with the advent of FAPI, you're able to bring in strong client as well as strong service authentication. That's the mutual TLS here. So I can strongly authenticate the client on my mobile device or the client on my desktop out to the backend services, right? Have them mutually authenticate each other. So now I've authenticated strongly everything that's in the transaction, the user, the client, the service. In addition, if I want to talk to backend services, for example, I can use things like Spiffy. This is another emerging standard coming directly out of the CNCF. And they're using X509 certs to authenticate workloads. Those workloads obviously correlate with OAuth clients on the backend services, now allow you to create that zero trust all the way from the front door, the user authenticating, down to the back door, some backend, maybe even obscure service by giving it a strong identity that's an X509 cert. Now, what we don't want to do is continue to use things like shared secrets, right? This is what we've been doing for the past 10 years, where I've got multiple instances of an application. I'm using a shared secret like an API key and pretending like that's strong authentication, because it's not. It's the same thing as a user ID password. And now as I look at how do I bridge that into my next generation of services, as well as my existing services, being able to plug into each and every API gateway, right? Being able to plug into each and every cloud, making sure that OAuth client ID really becomes that defining factor, that integration for federation between my IDP, taking the OIDC token, all the way down to any of my net new application infrastructures, Kubernetes, Istio, obviously net new APIs, functions, etc. So taking that one step further, now that I've strongly authenticated things, well, how do I start to bring in better authorization? Right? Because today authorization is typically very coarse grained, meaning can a user get to an application? And that's interesting, right? From an RBAC or PBAC or ABAC perspective, right? Where I get the entity, I get the group, I get some authentication, maybe some light geo attributes. But that really doesn't get us to where we need to go. And what I mean by where we need to go, I mean, I want to define the best possible user experience and saying, oh, user A can get to an application. That's great. But taking that another step further, I want to know what that application should look and feel. I want to understand what that user data has given to me, and maybe even prompt during the course of the application without hard coding into the application for additional information. And so authorization is really fundamentally changing. It's going from what can I do as a user within the application to also what can an application know about me? And then even incorporating things like fraud engines so I can know, did my context change during the course of this transaction? Did I switch from a regular network to a Tor network, right? Did somebody compromise my access token? And being able to take and munge all of that data together gives us the most context that we can have and allows us to make better authorization decisions in real time at the edge of the service that we're accessing, or even at the edge of the backend service that we're accessing. So we're able to now start constraining that user depending upon their security posture. We're able to do that in real time on a per transaction basis. And when I say transaction, I really mean client to service and then backend service to service or machine to machine. So being able to pull all of that together, now that I've authenticated things, I want to start thinking about how can I control exactly what transpires on the wire, for what data can be seen by which service, or what data even a user is consented to a service to knowing about them. And that's really where that consent comes in. And when we kind of wrap this all together, we say, oh, we want zero trust for our consumers, because our consumers definitely want zero trust from us. I want to authenticate the user. I'm giving them their biometrics back. I'm giving them part of their privacy back, or much of their privacy back. I also want to authenticate to the services, which I'm doing now via OIDC or I'm sorry, via OAuth or via SPIFFE. And then I'm authorizing exactly what can be known about a user and being transferred down to the service. Consent allows us to also say, well, what can that service know about the user? Let's be very definitive. Let's be very fine-grained about the consent aspect as well. Open banking has done a wonderful job at this, saying a user's got to be able to control what they consent to other services, or what data they consent to sharing. They've got to be able to say, I want to share my last name for 7 days or for 3 usages or out to these third parties. So being able to do a delegated control of consent. You're also able to adapt your user journey, reducing that friction even further by saying, well, at what point do I want to collect this data from the user? Do I need to know their account number the first time I see them come in via social login? Of course not. I only need to know their account number when I'm actually transferring money. Or I need to see their balance, right? So now we're able to actually say, okay, you prompt for the data you need when you need it, and do this again, all externalized from the application. So you're able to continue this very seamless, low friction user flow, starting off with FIDO, collecting data when you need to, authorizing only what's required in the application, authorizing only what the user is consented to granting the application, and then creating tamper-proof privacy on exactly what's allowed to transpire, or exactly what did transpire. What data was there? What data was accessed? How was it accessed? Who was it accessed by? What were they authorized for? How were they authenticated? All of the who, what, where, why, when is incredibly important to maintain and manage. So as we bring all of that together, right? Obviously, these seem like very complex topics, but the orchestration really becomes imperative, right, to maintaining and managing our success. If we look at the bottom half of the screen, what we see is we have our end users, and they're using FIDO, right? They're using FIDO to carry down their identity or authenticate to their clients and services, their mobile devices, their laptops, etc. And then they're able to essentially bring their own IDP, right? They're able to authenticate to it, maybe use social login, and that IDP brings in an OIDC token. That OIDC token works in conjunction with an authorization service, in this case, an authorization control plane that is multi-cloud, multi-gateway, multi-service aware. So you're able to now define all of your different aspects of authorization, your policy management, your policy governance, tying data to scopes in real time without the work of the developers doing it. Making sure that you're able to normalize what that data looks like so your applications don't have to adapt to different data types or different styles. And what I mean by that is sometimes for an IDP, last name will be last name. Sometimes it'll be surname, right? Do you want your applications to do the mapping on the back end? Of course not. You want to make it as easy as possible for your applications to adopt that authentication, identity, and authorization services. From there, we go into that OAuth token, right? And making sure that, again, you're able to use your existing OAuth service, or you're able to mint net new tokens on a higher speed service. Pass those OAuth tokens down to your different registered clients on the back end, your APIs, your gateways, your service meshes, who then might have intra-service communication. And maybe you want to use OAuth for that, which certainly is possible and achievable, or you might just want to use signed JOTs that are now going in between services, but again, only carrying the data that you need. Today, what we're seeing is companies are passing that same access token, right? That's typically very rich and sometimes very big in between those services, publishing all types of data that the service doesn't need to know. So moving from a, give you everything to a least privilege, moving from a give you everything to a least privilege, right? Least accessibility requirement, making sure the services only get the data they need at runtime when they need it. Now, a couple of questions we typically hear, right, is as we go there, how do we scale? We look at, rate limiting that's in some of the current IDPs, the SaaS versions of them, or we look at even the scalability issues with the monoliths that we have. And that's one of the main reasons to move to that cloud native architecture, right? We can get away from thinking about IDPs as these giant stacks that we have to either have managed for us in the cloud, or we have to deploy cross cloud and try and make them stretch into that multi-cloud world. Instead, by going to that microservices, those identity microservices model, excuse me, instead, going to that,
I'm sorry, can we
Oh.
restart at the top of that slide?
Oh, sure.
You didn't cover that much on this one, right?
Okay, not yet, no.
Okay, yeah, that'll just be a much easier, cleaner cut.
How are we doing on time, do you know?
My clock's at about 20. I think we're at really at 19 from when we started.
Sounds good. So one of the big questions that try that again. One of the big questions that we hear is, how about scale, right? We look at our existing IDPs and whether they're SaaS or on-prem, they have some serious limitations, either via rate limiting or via scalability on what they can do from a token mint perspective or what they can do from an authorization perspective, right? And so as we think about, okay, well, we're not really talking about scalability of the entire IDP. We're not talking about monoliths anymore. We're talking about moving into a microservices-centric architecture, right? In this case, when I move to mini or microservices for my OAuth service, well, I can move from the hundreds of transactions a second, right, and long-lived tokens that I'm using today into tens of thousands of transactions per second or token mints per second and very short-lived tokens, moving into transactional tokens, right? In open banking, this is already being used. It's called the intent-based lodging pattern. And being able to use that in a very robust perspective across all of my services becomes a powerful way to avoid things like account takeover, token replay, even things like excessive privilege, because I'm only giving the data that's authorized to be given in real time. That's one of those benefits, right, about how do we move to this cloud native architecture. We want to bring in the distributed services or to support distributed services. And what I mean, doggone it, I messed that one up. We want to bring in distributed identity to support distributed services, pushing authorization right out to the edge of the service with a distributed PDP while maintaining management of policies centrally. So I can ensure that only the data that goes is the data that's required. Again, principle of least privilege. We also want to standardize. What we hear is, okay, well, when we move to things like externalized identity or externalized authorization, it becomes the developer's responsibility, right? And once it's the developer's responsibility, the CISO, the regulatory bodies, et cetera, they no longer have the capability to understand or look into the code, right, to divine what the developer intended, or be able to even ensure that it hits the regulatory demands. So moving that into a centralized repository while still enabling those distributed authorizations, identity, and consent becomes a very powerful part of the tool, because now this gives you the governance as you go from one application to 2 applications to 10 applications to control, right, what the policies look like, how they're being replicated, what data is being passed, et cetera, all of those benefits. But now you can report, divine what's going on, and even understand how data is flowing in your environment. What IDP did it start at? What database did it start at? What application did it go to? Where did it end up, or what partner was it shared with after that? Right. And that becomes a very powerful way for your security team to both understand as well as to protect all of the different sensitive data elements, PII and otherwise, that are moving across your distributed services landscape. So again, looking at it from a managed centrally, distributed globally, right? Without that governance, without that inbuilt authorization, your developers are creating it, your developers are putting it into context, your developers are moving things around, building their own policies, or maybe not updating policies. Maybe they're not in compliance with CCPA or GDPR. With that centralized authorization, right? Now those auditable changes to policies are tracked, are known, are versioned, are signed, and then instantly enforced across all of the different services. So anytime you see that API spin up, cross cloud, cross API gateway, cross Kubernetes clusters, right? It's going to be protected in the exact same manner as if it was in your data center and had a hard-coded authorization policy. But now it's a distributed policy as code approach. So very, very powerful for allowing developers and your DevOps teams to move much, much faster, adopting identity, adopting authorization, and adopting consent. As we think about how we get there, right, I think that's pretty important, is looking at the old world and how that moves into the new world. So from an old world perspective, right, we have a lot of IDPs that are out there built for employees, right? And they even stretch them out from employee-based IDPs into consumer-based IDPs. But they didn't really make it out to that B2B2C or B2B2B or some of the more complex business arrangements that we're seeing everybody build today. Moving from long-lived sessions to transactional sessions, right? So no longer can you have a week-long, a 24-hour-long, even an hour-long session, right? It's too easy to take that session, capture it, replay, et cetera, and be at risk, be at real risk immediately. So instead, moving to transactional sessions that are only valid for milliseconds or seconds on the high end. Moving away from blanket privacy, right? Today, a lot of times you go to CNN.com, you grant them all of your access to all of your data by saying, oh, I accept your cookies. And instead move into object and intent-based privacy patterns. Moving away from things like SAML, XML-based, into OIDC and OAuth, right? Thinking about those as, again, that XML to kind of JSON transaction. And then again, obviously getting away from user ID passwords and getting into things like passwordless via FIDO. Monolithic architecture to distributed services, XACML to authorization as code, API keys, again, shared secrets, essentially user ID passwords, into SPIFFE, dynamic client registration under OAuth, making sure you have a strong way to both rotate those keys for your services, as well as allow them to register directly, moving from LDAP way to SCIM, and then taking these manual processes, right, that we've let our developers do or we've let our DevOps teams build because they need to get that project or that code out the door as quickly as possible, into integrated DevSecOps policies, where now as part of the application build process or as part of the application deployment process, identity, authorization, consent, and not just user identity, but also service and client identity are handled automatically, natively for those teams. Kind of repeating where we were at, right? Authorization really becomes this common glue, where it's now connecting the strong authentication of the user to the strong authentication of the services, to the strong authentication of the client, to the strong authorization of all of the data going across the wire. Again, taking those implicit and explicit protocols that are out there, we already have the building blocks, right? We have FIDO, we have OIDC, we have OAuth, we have SPIFFE, we have Rego, and using them to create a very rich, robust identity fabric that's covering your identity, authorization, consent, externalized away from your applications, and easy to understand in a graphical editor. So that's where, this all comes to building that zero trust for consumers, ensuring that it's zero trust for both the organization, zero trust for the user, meaning they're not submitting their biometric information, and they're also controlling consent. They're being very, very regimented about what data can flow where, what data can flow when, and ensuring that only the data they want to share is being sent to the application or being sent to the organization, and also being shared by that organization to other third parties. I'm Nathanael Coffing. If you have any questions, please feel free to get in touch. We're downtown Seattle, so if you want to stop by the office, happy to have you, and look forward to chatting further. Thank you.